Yes, class. Am I audible to all of you?
Yes, ma'am.
Alia, you have joined from two IDs. Mariam, Harsha. Okay. So yes, class, in the last class, we had started with thermal properties of matter. So basically, we had seen the concept of internal energy and how it is related to heat. So mainly, we had seen that whenever there is a temperature difference in two objects, there is a temperature difference. The object with the higher energy transfers a portion of energy to the one with lower one. And this imbalancement in the energy leads ultimately to the balancing of both the energies. So when these energies are balanced, the amount of energy that had actually traveled from one to another, we call it as heat. The term that is given is heat. So then we started with the concept of temperature. So we had seen how many types of thermometer are there, the principle of thermometry. We had seen what are the principles of thermometer and this different scales. So we didn't practice any question, I think. We didn't practice any question from this. Yes. See, this was the scale that we were discussing. Wherever a random scale is even given, subtract the lower fixed point divided by upper fixed point minus lower fixed point. And for some scales, this lower fixed point and upper fixed point, this is defined like the Celsius scale, Fahrenheit scale, Reaumur scale, Kelvin scale. For all these, you already have the lower fixed point and upper fixed point defined. So their differences can also be calculated. So here only, this ultimately becomes the main formula for which is very helpful in the calculation part also. Like this is saying calculate the temperature at which Celsius scale and Fahrenheit scale have the same reading. What was the Celsius scale portion? Tc minus 0 divided by 100. And what is this? Tf minus 32 by 180. TF minus 32 by 180. The question says they are having the same reading. So instead, what we can do, we can write temperature in Celsius is equal to temperature in Fahrenheit is equal to T. Both are the same. So it will be T by 100 is equal to T minus 32 divided by 180. 0, 0 will be cancelled. Equation will be 18T, or let's not cancel 0. Calculations will be easier with the zeros because 100 we'll be able to multiply. So 180T is equal to 100T minus 3200. So from here 80T will be equal to 3200. Okay, 180 minus 100. Correct. So 80, this will be minus 32. So temperature will be minus 40 degrees Celsius. This is the answer. Okay, one more question we'll see. Write it down. Now, class, I'll come back to these topics. First, let us start with thermal expansion of solids. So this is a topic, those who weren't even there in the last class, you all will also be able to understand what is meant by thermal expansion of solids. Now, thermal expansion, when I use the term, thermal means what? Thermal means heat. And expansion means to increase in area. This is to increase. So thermal expansion of solids means the solids area, volume, these quantities are increasing just because of heat. When the etiology behind is heat, we call it as thermal expansion of solids. Now see, thermal expansion of solid, this is also not of a single type. Firstly, we have linear expansion. Linear expansion is again incrementation in the area, in the length, and length is in one dimension. Second is superficial. Second one is superficial. Superficial means increment or change in the area. Fine. This is the change in the area which is happening. Third one we have, which is volumic. Also, you can say cubical. We use the term cubical, which is common. So this is cubical. Here you write area. This is in one dimensions actually. And here this is in 3 dimensions. 3 dimensions means you can consider the volume here. This is written in 2 dimensions. So increase in the dimension. It can be any dimension. If I say a rod is there, its diameter has increased after keeping it on the stove, let's say, because of heat that has been supplied. Basic reason, no, what happens is that, see, 2 molecules are very close to each other like this. 2 molecules are very close to each other, fine? Now, they are separated by a very small separation because this is at the molecular level. Okay, correct? This is at the molecular level. Now, what happens is that when this is kept on heat, when you are heating it, when this is kept on heat, the separation between the molecules will increase. If one molecule is here, other molecule will be here. Now see, this was just example given by 2 molecules. I was talking about 2 molecules only. So, and in your system, you have thousands of molecules. You have infinite molecules present. So if with 2 molecules, there is an expansion. So with so many molecules, how much expansion will be there? Right, so much expansion will be here. And if so much of expansion is here, then the body will obviously increase. 2 molecules are getting separated, either in length will increase like this, something is increasing in the area also, something is increasing in the volume also. So it is giving you the thermal expansion, means expansion of the molecules with the reason heat. So one by one we'll do. Initially, I'll start with this. Then you all will start answering the questions. Linear expansion, let's discuss. Then you can write it down, understand it, because then superficial and cubical, we'll do it very fast. Linear expansion means what? Linear expansion means initially the length at a temperature T0 was L0. Right? At temperature T, capital T, the length increases to capital L length. This is the length which is given. Fine. So obviously we have increased the temperature. T is greater than T0. So length has also increased where length is greater than L0. These things you have to remember. Fine. Now the change in the length, can you see there is this extra portion which wasn't present before? There is this extra portion which wasn't present before increasing the temperature. This extra something has been increased. What is the change in length? This change in length is proportional to 2 things. Firstly, it is proportional to the initial length L0. Secondly, it is directly proportional to the change in temperature. So if I'll combine and write it, I'll write it as delta L is directly proportional to L0 delta T. And we've always seen whenever we have a variable We have variables and we have to remove equal to sign. We have to remove the proportionality sign. What do? We remove the proportionality sign by putting the necessary constant at that position. So delta L is directly proportional to L naught delta T. So delta L will be equal to alpha. This symbol is alpha L naught delta T. We call it as coefficient of linear expansion. This we'll be studying coefficient of linear expansion. Fine. What was the change in temperature? If I'll tell you, this change in temperature was nothing, just T minus T naught. This was just T minus T naught. And what is the value of alpha from here? Alpha, if you look, it can be written as delta L by L naught delta T. Correct. Now come to the definition. See, before coming to the definition, delta L divided by L. Always remember, this is the fractional change in length. Whenever I ask you fractional change in something, or I ask you percentage, the only method that you will follow is change divided by original. That gives you fractional quantity. Change divided by 100, change divided by original into 100. That gives you the percentage value. So here, what am I saying? I'm saying this is the fractional change in the length. This is the fractional change in length. Fractional change in the length. So yes, how can you define alpha, which is the coefficient of linear expansion? See, fractional, if you look, very simple definition, you will just remember it here and there, right here and here. No need to even just rote learn all these things. Right now only you will remember. If you just revise once at home after the class, you will be able to remember this. Fractional change in length, that is the change in length by original length. So fractional change in length per unit degree Celsius change. Per unit degree Celsius change. We write the unit as either Kelvin inverse or degree Celsius inverse. So what was alpha here? Alpha was the coefficient of linear expansion. This is alpha. Coefficient of linear expansion. Understood? Fractional change in length means change in length by the original length. So fractional change in length per unit degree change in the temperature. Degree Celsius you can say but the best is that if you say per degree change in temperature, whatever is the, all right, whatever is the. Okay, what was the change in length actually came? I have been writing delta L, delta L, delta L. What is actually delta L? Delta L is the change. Delta L, no, delta L is the change in both the lengths. Delta L is the change in the length that has come. So how can I write the change? How do you ever write change? Final minus initial, that's how we write. What is the final quantity? The new length that has achieved. And what was the original quantity? That was the original length of the rod. So L minus L naught is equal to alpha L naught delta T. Let's bring this L over this side. So this will become L is equal to L naught plus alpha L naught delta T. What can we do common for the last step? We can at least take L naught common. So we are left with 1 plus alpha delta T. What are all quantities? L is the real length. This is the real length. What is L naught? This is the original length. This is not the real length. This is the final length. Not real. This is the final length. This is the original length. Alpha is coefficient of linear expansion. Coefficient of linear expansion. This is change in temperature. Change in temperature. Clear? This formula is also used. Both the formulas are same. It's just that we have substituted the value of delta L and have obtained it. All right. Write it down. This is the change in the length that has come. Write it down. I'll practice numericals with you. First, you will solve by yourself. question says length of the wire at 10 meter is, at temperature 10 degree is given 10 meters. So you have to find its length as 20 degree Celsius temperature. Coefficient of linear expansion is given C. Initial it's given as 10 meters for the initial temperature 10 degrees Celsius. Final length we don't know. Final temperature is given as 20 degrees Celsius. Alpha is also given 2 into 10 to the power minus. So L is equal to L naught 1 plus alpha delta T. So L is, what is L naught? 10. 1 plus 2 into 10 to the power minus 4. Delta T, 20 minus 10. See, delta T is T minus T naught, which is 10 into 10. So L is 10.02 meters. Quickly write it. Now, second is the superficial. Superficial, you will see area is increasing. This was a smaller area. In initial surface area was S naught. Initial temperature was T naught. Final temperature is T. Final surface area is S. This is very easy. This is not difficult. This thermal expansion portion. So change in the surface area will be equal to S naught delta T. Again, here also we'll have the constant. This is beta. There was alpha. Here it is beta. Alpha, beta, S naught delta T. Alpha is the coefficient of linear expansion. Beta is the coefficient of superficial expansion. And again, delta S is equal to S minus S naught. What is beta equal to? Beta is equal to delta S divided by S naught delta T. Again, if you will see, delta S divided by S naught. This is equal to fractional change in the area. So how can you define the coefficient of superficial expansion? Fractional change in area per unit degree Celsius change. This is again Kelvin inverse or degree Celsius inverse. So you can write this as delta S minus S naught is equal to beta S naught delta T. S naught you will shift it here. You will get again the same equation as you have received it for the linear one. Fine. Question also, initial surface area is given as 20 meters square. Look, area of a square is 20 meters square at temperature 10 degrees Celsius. Calculate area of the square at the temperature 20 degrees Celsius. This is saying, and coefficient beta is given as 5 into 10 to the power minus 5 Kelvin inverse. So S is equal to S naught 1 plus beta delta T. So delta T is 20 minus 10. Here is 10. So it will be 21 plus 5 into 10 to the power minus 5 into 10. So surface area would be 20.1 meters. Like this one. One more is left. First, write this down. Then I'll discuss that. Quickly write it down. Yes, next, last topic is cubical expansion. So this is the volumic expansion, change that occurs in 3 dimensions. So change in volume is directly proportional to initial volume into delta T. Here the constant is coefficient of cubical expansion is gamma. Again, we can say this is fractional change in volume per unit degree change in temperature. So delta V is equal to V minus V naught, where you put the value V minus V naught is equal to gamma V naught delta T, and V is equal to V naught plus gamma V naught delta T. You take V naught common, 1 plus gamma delta T. Exactly the same. By now, you must have remembered the pattern. One last question for today. I wanted to complete this topic as well, thermal expansion of solids. This revise. Everyone should revise and come. On Thursday, we'll have the class. So by Thursday, you all should remember it. Volume at 10 degrees Celsius is given as 100 meter cube. Calculate its volume at the and density at initial is given. Temperature is given 20 degrees Celsius and gamma is given 10 to the power minus 4. Mass is given for density. Very easy. V is equal to V naught 1 plus gamma delta T. First, we'll find out. V is equal to 100. 1 plus 10 to the power minus 4. 20 minus 10 is into 10. So, volume is equal to 100.1 meter cube. All right. So density, when you have to calculate density, is mass by volume. So density will be mass is given as 10 kg, volume is given as 100.1, which should be around 0.99 kg per meter cube. How have I got 10? See, what is the change in temperature? Change in temperature is T minus T naught. So T is 20. This is by 20 minus 10 is equal to 10. Okay, clear. Write down this. Easy. All these three you have understood. Linear, volumic, cubical, superficial. Khadija, Khudeja, Harsha, Alia.
Yes, ma'am.
if you all have completed till here, you can start leaving. Those who have their class right now, you people can take a break of 5 minutes. After 5 minutes only, I'll start the class. Other students of the previous batch, you can start leaving, revise this. This completes your one topic, thermal expansion of solids. In the next class, we'll start with another topic. Thank you so much.